All right, everyone, let's spend some more time looking at how to graph exponential functions, okay? Let's look at graphing exponential functions. So I have my exponential function right here, y equals 2 to the x power. That's an exponential function, right? Often we've been writing these in function notation, like we would see f of x equals, in this case, 2x, or g of x would equal, in this case, 2x. But we know that writing y equals is really the same as writing f of x equals, right? Because where do we graph the values of the output of a function? Always on the y-axis, right? Okay, so let's look at this. And also let's take a note at another thing. We know that, and let me write it over here, right? We know that the form of our exponential functions, right, is always a times b to the x power, right? Where a is the initial value and b is the ratio, right? So this y equals 2 to the x power is still in this form, except it's just in the simple form where a is equal to 1, right? 1 times 2 to the x power. All right, just so we're comfortable with that and aware of that. Okay, so let's get to graphing. So how can we graph a function? Well, we can pick different values of x, right? Plug in those values, get the corresponding value of y, and then graph that ordered pair on the coordinate plane, right? All right, so let's pick out some values of x. Let's pick -1, -2, 0, 1, and 2 to start out with, okay? Let's just pick those to start out with. That'll give us a good idea of what this function looks like, right? And you might already have a pretty good idea of what this function looks like because we already sort of know how the behavior of exponential functions, right? Okay, so let's start here. Let's start at 0 because 0 is really easy to graph, isn't it? So yeah, let's start at 0. Let's start at x equals 0, and I'm going to write over here, if x equals 0, right, y equals 2 to the 0 power, right, which is equal to 1, right? And that makes sense, right, if we know that our initial value a is actually equal to 1 in this case, right? If we know that our initial value is 1, it should make sense that when we plug in x equals 0, we get the output 1, right? Okay, so that means we have a point 0, comma 1, right? Or 0, comma 1 right here. 0, comma 1, right? So at x equals 0, we're going to have our value on the y-axis be equal to 1. So let's create that point right there. All right, very good. Okay, let's get rid of this work here, and let's go on to, let's deal with the positives first. All right, let's deal with the positives. So let's deal with x equals 1. Well, when x equals 1, y is going to equal 2 to the first power, which is just equal to positive 2, right? So we have a point 1, comma 2, right? So next to our value x equals positive 1, we can fill in y equals positive 2 here, right? So let's graph that point. X equals positive 1, y equals positive 2. We can graph that right there, right? Okay, let's make some more room so we can keep at it. Let's make some more room here. All right, what about x equals 2? Let's go to x equals 2, right? Well, at x equals 2, y equals 2 to the second power equals 2 times 2. We know that equals 4, right? So we've got a point 2, comma 4. Makes sense? So we got 2 on the x-axis, and let's go up to 4 on the y-axis, right? That's going to be right around here, isn't it? Yeah, it's going to be right around there. All right. Let's get rid of this. Let's do one more positive x value, okay? Let's do one more positive x value. Let's do x equals 3, okay? Let's do x equals 3. We're going to get x equals 3. We're going to get y equals 2 to the third power, right? See, we just plug in x. We just plug in the value 3 wherever x is in the formula for the function. It's going to equal, remember, 2 times 2 times 2. We know how exponents work. That's going to equal 8, right? 2 times 2 times 2 is equal to 4 times 2 is equal to 8, right? So we're going to have a point 3, comma 8 when x equals 3. y equals 8, right? So let's find the value 3 on our x-axis, and let's try to find the value 8. Okay, 1, 2, 3, 4, okay, 5, 6, 7, 8, right? Somewhere like right here, right? Right around there. 3, comma 8, all right? So now let's look at the negative numbers. And also, well, first of all, let's just look at what's going on with the right-hand side of our function, right? It looks like the values are increasing very quickly, right? From one point to the next as we go to the right, or as the value of x increases positively, we can see that the output of the function is growing very quickly, right? And we should be used to that relationship from how we looked at exponential functions in the last couple lessons, right? Okay, so now let's look at negative numbers. Let's look at -1. First of all, I should rearrange these, right? -1 should come before -2, shouldn't it? There's -1, there's -2. Let's try to plug in x equals -1, right? Okay, that means y is going to equal 2 to the negative first power. Hopefully we remember some of our properties of exponents. We should know that this is equal to 1 over 2 to the first power, right? When you have a base raised to a negative exponent, that just means you flip it into a fraction and you raise the denominator to that power, right? So 2 to the negative first power is equal to 1 over 2 to the first power. We know that just equals 1 over 2, right? So when x equals -1, y equals 1/2, positive 1/2, right? So first of all, let me try to get some room here. Let me try to get rid of the upper parts of these x value markings, okay? All right, this will make it easier for us to work. So when x equals -1, y should equal positive 1/2, right around there, right? Positive 1/2, right? Okay. And finally, what about when x equals -2, negative dose? When x equals -2, right? Y is going to equal 2 to the -2 power, right? That's going to equal 1 over 2 to the second power, going to equal 1 over 4, right? So y is equal to positive 1 over 4 when x is equal to -2. All right, now we're getting smaller and smaller and smaller, right? It's going to become more difficult to graph that, won't it? For example, if we then, to one more example, we get rid of this here. Okay, there we go. And if we just also tried one more, x equals to -3, it's going to get us to y equals 2 to the -3rd power, right? Going to get us to 1 over 2 to the 3rd power, right? That's 2 to the 3rd power. That's going to equal 1 over 8, correct? So when x is -3, y is going to be positive 1 over 8, right? So if we look at x equals -3, our y is going to be really small, right? Positive 1/8. That gets really small, right? Okay, so let's look at this graph now. We can see that it intersects the y-axis at x equals 1, right? And then we can just try to connect this in a smooth curve, right? In a smooth curve. And what happens as we go beyond x equals 3? What if we went to x equals 4, x equals 5? Well, we'd be raising 2 to higher and higher powers, right? Which would mean we'd be multiplying positive 2 by itself more and more, right? Which means that this graph would just keep growing at an extremely quick rate, correct? That's not exactly the best drawing. It should be smoother than that, but hopefully you get the idea, right? In fact, let me try to connect this a little better. Let me try, if possible, to connect this a little better, right? It's just going to keep on going up smoothly like that very quickly. And what's going to happen to the left of the y-axis, right? what in the world happens to the left of the y-axis? Well, we're going to be raising 2 to increasingly negative powers, right? And remember what raising a number to a negative power does, right? That puts that number into the denominator of a fraction. So you're going to be getting fractions with increasingly larger denominators, right? So for example, if we put in x equals -4, right? If we put in x equals -4, we'd get y equals 2 to the -4, right? Which is, which is 1 over 2, the fourth power, right? Which is actually 1 over 16, which is really small, right? It's like once you get to 1 over 16, it becomes hard to even really graph that right. It's hard to even get that close to the x-axis down there, right? So what happens as you go to the left on your x-axis, or as your numbers or as your x values decrease or become more and more negative, the value of the function begins to get very small, right? It begins to get very small, but it never actually hits zero. Okay, it's never going to hit zero because you can never raise a number to a power to get your output to be zero, right? Because if you raise a number to the 0th power, you get 1, right? If you raise a number to a positive power, right, you just get, positive output. Positive number times itself over and over and over again is never going to be zero, right? If you raise it to increasingly negative numbers, you get 1 over that number raised to increasingly high powers. So you get really, really, really small positive numbers, right? But you're not going to get zero. So the output of an exponential function, or at least a simple one like this, is never going to be equal to zero. And your graph is going to look something like this, okay? Where you pass the y-axis, or you intercept the y-axis at the initial value, which was 1 in this case. And as your x values increase, the value of your function increases very quickly. As your x values become more negative, or as they decrease negatively, the value of your function becomes extremely small.